Hi, this lesson is on section 6.5 again. This is day number 2, and this time we're going to talk about multiplying radicals. This too is kind of going to follow some similar rules with fractions. Once we multiply fractions together, we always want our answers to be reduced or in simplified form. Well, the same thing is going to be true with radicals. Once we multiply them together, we want to check to see if our radicals are simplified all the way. Okay, so to start with here's a couple that we're going to take a look at. What if I had 2 square roots of 3 times 5 square roots of 2? Now in the previous lesson with adding and subtracting, we talked about the radical part having to be the same. But with multiplying, just like with fractions, we don't have to have common denominators with fractions when we multiply. Same thing here with radicals, we don't have to have common radicals. They don't have to be the same, that's perfectly fine. And here's kind of a little rule with multiplying radicals together. We can multiply the big numbers with big numbers, as I like to call them. 2 times 5 gives me the 10. And then the radical part with the radical part. Okay, only numbers under the radical can be multiplied with other numbers under the radical. And 2 times 3 is the square root of 6. And I always ask myself, what about the square root of 6? Is that reduced all the way? Well, there again, as you get comfortable with these and as you get good at them, you'll remember them. Otherwise, look at your factor sheet. Okay, factor sheet on 6, there's square root of 3 and the square root of 2, but neither one of them are in black. They can't be reduced any further. So our answer is going to stay 10 square roots of 6. Okay, and is multiplying radicals as simple as that? Yeah, for the most part it is. Okay, here's another one. What if I had 3 square roots of 2 times 5 square roots of 6? How about this one? Okay, again, if I multiply the big numbers with the big numbers, 3 times 5 I get 15. The radical part with the radical part, square root of 2 times the square root of 6 is 12. This time though, if I look at 12, and maybe you're pretty familiar with this, 12 is not a perfect square, but it can be simplified. I can simplify it, and again, if I use my factor sheet, 4 and 3. Square root of 4 is a big 2. 2 times 5 I end up with, or 2 times 15 is 30 square roots of 3. Okay, so once we multiply them together, we just have to make sure that radical, check that radical to see if it can be simplified. Okay? Yeah. Okay. How about another one here? Just a couple others. How about something like this? Okay? Now, this one, if I kind of follow the same little rule I had, 4 times 3 is 12. Okay? And then if I did the square root of 75 times the square root of 20, that's a big number. Ugh. 75 times 20, it's a square root of 1500. Okay? Now, obviously 1500 is not on your factor sheet. That's a huge number. And off the top of your head, maybe you know a number that goes into that is a perfect square, and you could certainly factor tree it and so on from there. Okay? Well, I'm just going to show this. I could do 115. That would work. The square root of 100 is 10. Okay? And the square root of 15 does not have any black ones. So I'd end up with 120 square roots of 15. Okay, and that's one way to do it. Okay? Another way to do it is kind of like when you multiply fractions. Rather than multiplying all the way across first and then reducing, could you sometimes do some cross-canceling first? Sure. Okay, well I could do the same thing. How about I simplify my radicals first? What if I did 25 times 3? That's 5. 5 times 4 is 20 square roots of 3. Okay? Here I could do 5 and 4. The square root of 4 is 2. 2 times 3 is 6 square roots of 5. Okay, so I simplified it, made it much smaller, a little more user-friendly. And now let's multiply big numbers with big numbers is 120. And the square root of 3 times the square root of 5 is the square root of 15. And you can see they're the same answer. So you can do it either way. I think the numbers that you're going to see mostly for the most part are going to be small numbers that you'll be able to do the original multiplication in your head. But when in doubt, you can certainly simplify them first. And notice I needed a calculator to do 20 times 75. But over here I didn't need one. Okay, so again, it's up to you. Okay, we'll see how it goes. Okay, just a couple others here. How about this one? 5 square roots of 2 times 3 square roots of 2. I'm going to point out a little pattern here. There's a shortcut. Okay, I see 5 times 3 is 15. The big numbers. Now how about the square root of 2 times the square root of 2? Some of you are thinking the square root of 4, and the square root of 4 is 2. And 15 times 2 is 30. Notice the radicals went away there. The thing I want to point out is anytime we multiply two radicals together, it just turns into that number. Kind of like i's. When we did the square root of 1, negative 1 times the square root of negative 1, it was negative 1. Okay? But anytime, and you're going to see this quite a bit here, the square root of 3 times the square root of 3 is 3. The square root of 7 times the square root of 7 is 7. The square root of 92 times the square root of 92 is just 92. You can see a little bit of a pattern here. But whenever you have two of them that are the same, it just turns into that number under the radical. Okay? All right. One last one here before we move on here. How about this one? How about some variables? 5 times the square root of 20x cubed times 3 times the square root of 2x squared. Okay? Well, let's give this a whirl once. Again, I like to look at the big numbers out in front. The square root of 5 times the square root of 5 is 15. I'm sorry, just regular 5 times regular 3. 5 times 3 is 15. Now how about the stuff under the radical? Under the radical, 20 times 2 is 40. And how about the variables? X to the third times x to the second, we add them and we get x to the 5th power. Okay, so I multiplied. Now I have to look at that stuff under the radical and see if I can simplify it. Okay, if I looked at 40, I think on my factor sheet, the black ones are going to be 4 and 10. The square root of 4 is 2. 2 times 15 is 30, with the square root of 10 left over. Okay? But that leaves me with x to the 5th. Okay, if you remember from the previous lesson here, I have the square root of x to the 5th. How many times does 2 go into 5? 2 goes into 5 2 times, so I get an x squared out in front. 2 times 2 is 4. That leaves me with a remainder of 1. Okay, so we can multiply these with radicals and variables. Okay, I'm going to try one more here. How about this one? 3 times the square root of 15x to the 4th times 2 times the square root of 10x to the 6th. Okay. Well, let's look at big numbers. 2 times 3 is 6. That's okay. The numbers under the radical, 15 times 10, is 150 x to the 10th. Okay, now, good news, 150, it's kind of a bigger number, but it's on your factor sheet. Okay, and if you looked on your factor sheet, this would simplify into, the two you would want to use would be 25 and 6. And the square root of 25 is 5. And 5 times the big 6 out in front is 30 square roots of 6. Okay, notice how I treat that variable part, the x to the 10th, just totally separate of the 150. Okay, but speaking of that x to the 10th, we're dealing with a square root. Does 2 go into 10? How many times does 2 go into 10? It goes in there 5 times. X to the 5th. It goes in there evenly and it does not have any remainder. There it is, 30. X to the 5th square roots of 6. Okay? So in multiplication, it's multiplying big numbers with big numbers, the numbers under the radical with other numbers under the radical, and then simplifying the radical part if it can be simplified. Okay? There's two other types of problems we're going to see with this. Okay? We're going to see a little distributing. 4 square roots of 3, 2 square roots of 5, plus 5 square roots of 2. Okay? Can we multiply these together? Okay? Well, we can distribute. Again, big numbers with big numbers, radicals with radicals. 4 times 2 is 8. 3 times 5 square roots of 15. If I take that times the second part, 4 times 5 is 20, and 2 times 3 is 6. Okay? So we multiplied them, and now I have a little expression that we want to check to see can they be added together. Well, if you think back to the previous lesson, in order to add and subtract these, the radical parts have to be the same. and they're not the same. And as we also saw in the previous lesson, sometimes we can simplify these. The only thing I can do here is 5 and 3, and that's 3 and 2, and doesn't get us anywhere. Okay, so this particular one, that's the end of the road right there. 8 square roots of 15 plus 20 square roots of 6. Okay, but the idea is the same with distributing. Okay, we're going to practice just a couple other ones of these. 4 square roots of 2 times 3 square roots of 2 plus 2 square roots of 6. How about this one? Okay, now I mentioned this a few minutes ago. If I distribute, if I take this number and I multiply it to the first ones, 4 times 3 is 12 with the big numbers. The square root of 2 times the square root of 2, hey, it's the same number. The square root of 2 times the square root of 2 turns into a big 2. And 12 times 2 is 24. And the radical goes away on that one. Okay? Then I go to the last part. 4 times 2 is 8. 2 times 6 is 12. Okay? So I multiply them. I still have a radical. And this time 12. 12 does have some factors that are perfect squares. I can do 4 and 3. And the square root of 4 is 2. So I end up with 24 plus 2 square roots of 3. I still have 2 parts to my answer. Okay? But the second part, the radical, has to be simplified. Okay? Make sure you show me your work on how you're simplifying that. Make sure you show me your work on how to get these 2 numbers as you distribute through. Okay, I need to see that just so we're all crystal clear on that. Okay? 2 last types of problems you're going to see. Okay? Can we FOIL with radicals? Okay, how about this? Negative 3 plus 5 square roots of 3. Negative 3 minus 2 square roots of 3. Okay, let's FOIL. Okay, I'm going to take the first number and distribute it. Negative 3 times negative 3 is positive 9. Then I'm going to take negative 3 times this one. That looks like it turns into positive 6 with the square root of 3. I then go to my inside term and I multiply it here. 5 times negative 3 is negative 15 with the square root of 3. And the last one's the tricky one. Okay, let's look at the last part here. 5 times negative 2 is negative 10. But I have a square root of 3 times a square root of 3. The square root of 3 times the square root of 3 is a big 3. And 10 times 3, this turns into a negative 30. And again, the radical disappeared. Okay, when I FOIL here, I'm then look for like terms. Well, I see my regular numbers, 9 minus 30. And if you did that on your calculator or wherever, that's going to be negative 21. Okay? And then these 2 guys right here in the middle. This time they happen to both have the same radical. They're both square roots of 3, so they can be combined. 6 minus 15 is negative 9 square roots of 3. And there's my answer. And once again, these things can be they can be switched around. They can be in a different order. Doesn't matter which one comes first, but just make sure we have the correct signs. Okay? All right, that's a FOIL problem. Okay? I'm going to do one last one. This is another type of problem you're going to see. What if I had 3 square roots of 5 plus 2 square roots of 2 squared? What if we have that quantity squared? Now, once upon a time, we did learn a little shortcut. I think a pattern with perfect squares and things, but for the most part, most people didn't remember that, so what it means to square is we're going to write it twice. So you're going to see a couple problems like this, and then you're going to have to FOIL it out. And again, show me a little bit of work. Okay? So here we go. Let's give this a shot. I'm going to start with the first one and go here. Big numbers with big numbers. 3 times 3 is 9. Square root of 5 times the square root of 5 is big 5. That turns into 45. The second part. 3 times 2 is 6. Square root of 5 times the square root of 2 is the square root of 10. Maybe I should have written that down here. Plus 6 square roots of 10. I'm going to take this one then, and I distribute it to that one. Looks like I get another 2 times 3 is 6. 2 times 5 is square root of 10. And then last but not least, I look at the last number. The 2 times 2 is a big 2. No, it's not. Sorry. 2 times 2 is 4. And the square root of 2 and the square root of 2 is another big 2. And that turns into 8. Okay, and the radical disappeared. And again, if I combine my like terms, it looks like my coefficients, or not my coefficients, my constants, 43 plus 8, 45 plus 8 is 53. And then I have 6 square roots of 10 plus another 6 square roots of 10. I get 12 square roots of 10, and there I have it. Okay? So when we have a quantity squared, just write it twice and FOIL. Okay? But again, with multiplication, 2 things to remember. Multiply the big numbers with big numbers, the numbers under the radical with other numbers under the radical. Okay? And once you get that radical at the end, make sure to check and see if you can simplify it. And if you can, do your factor trees and do it. All right, thanks for tuning in.